Hi, I'm here to talk about Neptune. I'll give a short presentation and then I'll follow it up with a live demo. Neptune provides remediation as a service for your DevOps teams. With Neptune, you get less alerts and more uptime. So the beauty of this is that you can cut down your mean time to resolution a lot. And also, your engineers don't need to wake up for mundane alerts because Neptune automatically fixes them. Let's see how Neptune fits in your DevOps ecosystem. We don't do monitoring and we don't do alerting. Instead, Neptune integrates nicely with your monitoring tools like New Relic, AppDynamics, Nagios, Thousand Eyes, and so on, and PagerDuty. And when an alert occurs, it can automatically run a corrective action. So in a nutshell, Neptune does three things. One, analytics. It gives you interesting analytics around what are the top 20% of your alerts that are causing most of your pain. Number two, context. For complex problems which require manual investigation, it will gather all the context that you're going to run anyway manually so that the on-call engineer can troubleshoot the problem in minutes instead of hours. Finally, number three, remediation. If it is a known problem, it will just fix it automatically. If you look at the incident response lifecycle, only 5% of the time is spent in sending alerts. Rest of the 95% of the time is spent in troubleshooting, looking at logs, graphs, web page snapshots, and service level health checks, and so on. And once you have root caused the problem, you need to run a resolution runbook on a single machine or a set of machines. Sometimes you might run Perl, Python, or Bash scripts. And alternatively, you could run an auto-scaling action in response to an alert. Finally, you want to have an audit trail of all the actions that are performed by Neptune or even manual, even for manual actions for better data-driven postmortems. So Neptune does that automatically for you so that you create the tight feedback loop between devs and ops. So what Neptune does is it automates the 95% of this incident response process, which is very much manual. You can get started in 10 minutes. It integrates nicely with these most popular monitoring tools, and it can work with cloud or on-premise infrastructures. In the demo, we will demonstrate two use cases. One is a simple use case. Whenever there's a high memory alert, you capture thread dump and then restart the process. And the second one is a more complicated example where the application is experiencing high error rate, and we'll demonstrate how Neptune helps to investigate that problem faster. So let's say you just onboarded Neptune. We will ask two questions. One, what are the monitoring tools you're using, and what infrastructure are you running? Let's start with the monitoring tools. If you're running tools like Datadog or New Relic or PagerDuty, for example, we just ask for your Datadog API key and then Datadog application key. And similarly, if it is a PagerDuty, we'll ask for your PagerDuty API key and then a subdomain name. And we have a pretty tight integration with them. That's all you need to do. And we support all these other monitoring tools as well, like Nagios and so on. So after this step, all your alerts are automatically piped to Neptune. Step two is your infrastructure. If you're running on Amazon, we just ask for your IAM read-only key pair about your access key pair and secret key. And then you can run this one-line command which will install a Neptune agent, and you can control what user the agent runs as using the nagent user. We also have chef and puppet recipes available so that you can easily deploy it across hundreds or thousands of machines. And we support Linux, Mac, and Windows agents as well. So easy. In 5 to 10 minutes, you should have onboarded step 1 and step 2. And there's an optional step 3 where you can specify your own GitHub repository for storing your runbooks. And as soon as you're done, you'll be taken to a dashboard which shows all the open incidents. This is a one-stop alerts and actions dashboard for all your monitoring tools. So it aggregates alerts from all those sources, and then it shows you, so these are all your open incidents across Datadog, Nagios, New Relic, and CloudWatch. And these are the recent resolved incidents. And here are the incident analytics. So what are the top 20% of my alerts that are occurring most often? And what are the alerts that are taking up a lot of my time? I can also sort this by MTTR. So that way I can see the top 20% of the alerts, and then I can either do partial automation or full automation about those alerts. So let's take a look at one of the examples that we wanted to demonstrate, like a high memory alert. In this case, it's a high memory alert. It came from Datadog. You have like quick pointers back to Datadog that are showing, okay, uh, here is the alert that got triggered by Datadog, and here is a quick JSON that was sent by Datadog, and here is the graph snapshot for the memory alert, and it currently is resolved. And here are the actions that Neptune has performed by default. Since it's a memory alert, it automatically captured the memory used graph and memory total and then memory swap used graphs for you. And then it also ran what are the top 5 memory consuming processes for you. So that way you can quickly see which process is taking up like most of your memory. And once you have analyzed the problem, you can run a manual fix it action now that you understand the root cause. You can run a fix it action which actually restarts. Okay, I want to run it on the same host that sent the alarm. I want to do a restart process, restart a given service. And then you can run this action and then it will restart the process, and then now your problem is gone. Let's see how simple it is to create a rule like this. You come here, you come to the rules and then hit a create rule button, and then you select data source as triggered source as Datadog, and you select your alarm, which is a memory alarm, and then you select action type, which is an execute script action, and then you select trigger host, and then you specify, okay, here are all the default runbook templates or whatever runbook templates scripts that you already have. We can just we combine both of them and then make them available for you, and then you can run your own script. You can run it in like Perl, Python, Bash, any language of your choice, and you can also do like a quick dry run as well if that's what you want to do with a run now, and then it will show you the output right there. And you just give it a rule name and then you're done. And then we also have something called as like a flapping protection, which ensures that you don't do too much automation. So if it is happening too many times in a very short time window, we're going to escalate it automatically for you. So if it is a high memory alert, we automatically figure out the thread dump and then figure out what are the top processes that are taking up too much memory and then restart the process. Let's look at a little bit of a more complicated example, which is like a high error rate. In this case, the incident came from New Relic and it got opened at this time and then it got resolved. It took about like 9 minutes to resolve the problem. And here is a quick link back to New Relic, and here is the JSON that was sent by New Relic about the alert metadata. And Neptune ran a whole bunch of actions to help you investigate this problem, to investigate this error rate problem. Here in this case, it captured the last 100 lines of your application Heroku log files. And it captured the average response time by your tier for the last 6 hours. Because you want to get like whenever there's a high error rate, you want to also look at the latency. And then it captured like your error rate trend for the last 6 hours as well. And finally, it ran a command line script on all the hosts that are backing this particular application. You need not tell Neptune which hosts are running this particular application. Neptune will dynamically figure it out from New Relic and from the alert. So this is where the trigger intelligence comes in. So we ran the script automatically for you, and then you can see which of your hosts is experiencing any problem. If so, you can do something for that on that host to fix the problem. Since it's an error rate alarm, we automatically plotted you the request rate and the error rate trends. So you can see the scale of the impact of this problem. And finally, you can run a manual troubleshooting action. So for every alert that you get, every time your New Relic error rate alert is fired, you're going to automatically get all these diagnostics. And then an on-call engineer can make use of these to make faster decisions. Let's see how simple it is to configure a rule like this. So since it's a New Relic alarm, and I'm going to select like error rate alarm right here, and then I select the error rate, And then in this case, the first action I want to do is execute script, and then I want to get some logs. So what I'm going to do is like I'm going to do tail minus f var slash app.log, and then it is capturing the last 100 lines of the log file for me on the same host. And then I'm going to select another action, which is a graph snapshot. I want to capture from the graph snapshot from this particular host. I want to capture some metrics. I can say I want to capture the error rate metrics from Neuralink. Here we go, search all your error rate metrics, and then you can say system network all errors, system all received errors. You can simply get nginx logs. You can simply plot the graph to see how the graph looks like. And then you can also do some more actions, web page snapshot, and you can say http.status.aws.amazon.com, where you can see the status of the dependent services. And finally, you can also do a cloud API action, which can start, stop, reboot, terminate an instance, or you can do like a CLI action, where you can write a custom AWS CLI script of your choice. And you can also get logs from Splunk, Sumo Logic. All you have to do is just replace your search query. In this case, it is firing off getting all the log entries which have status greater than 200. And then you just give it a rule name, and then you're done. So it's actually very simple to set up and then very quick to set up. And yeah, and then once you're done with that, you can actually see all the use cases, all the most popular use cases right up in the use cases page. And whenever an incident is fired, you're going to get an email like this that says, okay, this particular error rate failed, and here is the output of all the commands that we ran. And you're going to get this information on your Slack channel as well. If you see that, like, you're going to get all the graphs and then output of the scripts in your Slack channel. So that's it. So it's actually incredibly simple to set up and there's a 2-week free trial. A Neptune engineer can actually come on site and then set it up for you if you need any help. Thanks for listening. Bye-bye.